All right, hello and welcome to the Spirent tutorial. On this particular lesson, we're going to be focusing on how we can use Spirent to act as a simple multicast source and receiver. So obviously some of our use cases here are anytime you need to do something like populating M routing tables or populating snooping tables, or basically anything where you need actual multicast traffic. Now the one benefit here compared to say an IXIA is that Spirent will allow you to generate a host that follows the IGMP protocol very easily. So it will respond to membership reports, it'll send joins, it could send leaves, it could do whatever you want, just as if it were an actual client. So let's go ahead and see how it's done. Now I've got a couple things set up here. I've got my switch in the background, and right now there is nothing configured. I've got no snooping groups, but I am configured as the snooping querier. The interfaces I'm going to be working with here are 101 and 102, which are both access ports on VLAN 10, but this particular demo could be either anything on L2 or L3, really doesn't matter. And then in the background, I've got some ports that have been assigned to me from Kalo. Now, normally your Spirent ports will automatically come in a pair. In this particular example, Kalo has cabled up one port from one pair and then another port from another pair. But normally we'll use both of them. Now, the first thing I want to do is I want to go over here and copy out the IP address of the server associated with the interfaces I'm going to use. And then I've got my Spirent VM over on the right. This is a remote desktop session. And there are a couple different applications we could use here. We see there's app 3.62, 4.0, and 4.69. A good way to check which one you should be using is just open up a web browser and then pop in the IP address of that server that was taken from Kalo. So this is the 120.38. And that'll pull up the server's main web page where we could easily see that this is server version 4.69. What is that? 9486. If you ever want to download that particular version, maybe it's not on your VM, you can click this link right here where my mouse is, and that'll allow you to download the version of Spirent in question. But now that I know this is version 4.69, I'll double click that and allow the application to load. Now, we will still need the IP address of this particular chassis, so it typically takes about a minute or two for Spirent to load up. And the initial splash screen is going to be for some just quick start wizards, which for this demo, we're not too concerned with. So this is the screen I was talking about, this getting started window. We'll go ahead and close that out. And I'm going to click this button up here, connect to chassis and reserve ports. Now you are probably not going to see that one chassis there. Instead, you want to click the create and connect option. And then the first dropdown, connect to physical chassis. And then put in the IP address of the chassis you're looking to connect to. In my case, I've already done that. And so I can simply open up the ports. And now I can take the ones that are associated with my Kalo case. So I can see that that's going to be slot 2, ports 1 and 2, and then slot 1, ports 3 and 4. And they do have a little bit of CDP visibility here, so it sees that at least port 3 is connected to the spirentdemo.cisco.com switch on port TE101. So I'll click 3 and 4, and then I'll hop over to slot 2, and connect to ports 1 and 2, and then hit OK. And now Spirent will start to take ownership of those interfaces. It'll put a basic level of config and sync on there. That's this process here. It typically takes about 30 seconds to complete, at which point I should see port 1, 3, and 2, 2, which are the ones going to my Kalo recreate, are active and ready to begin configuration. So the first thing I'm going to do is I'm going to make port 1, 3 my multicast source. And so we need to break this up into a couple different methods. First, I'm going to go to the devices of port 1.3, and I'm going to click the add button up top here. What this is going to do is that's going to pull up the wizard to create a device unique to this interface. I'm going to make sure only port 1.3 is selected. Then go to next. I'm going to do none. This is going to be a traffic only device. It's going to be my multicast source. It's going to have an IPv4 address. I'm not using v6. And because it's an access layer port, I am not going to select a .1q tag. If you were configured to use a trunk, then make sure that this option here is selected. I'm going to go next. My device is per port. So in this case, I'm just going to have a single device on this particular interface. And I want it to have a starting IP address of 10.10.10. Let's say 10. The default gateway should be .1, which is already set on the switch. I want to remark my TOS diff serve bit to be 0. That's just a personal preference of mine. I like everything DSCP0. And I'm going to leave all the other settings as is. Now, for some reason you want to have a lot of unique multicast sources, you could do that as well. So if I add a 0 to the number of devices per port, then the step here becomes relevant. And what this will do is it will now increase the IP address of all those sources, starting with this particular IP. So if I hit next in order to get to the preview, I'll see there's my 10 devices, 10 through 19, starting at IP address .10, and they all have the same common gateway. So we'll just, for the sake of argument, we'll go ahead and keep that basic config, and I'll hit finish. And now I need to create my multicast client. So for that, I'm going to hop over to port 22 here. This is going to be my client. I'm going to go to devices and follow the similar behavior. I'm going to go to the add up top with devices selected. Now I'm going to make sure only port 22. This is only the port I want to be my multicast receiver to be. Then I'm going to hit next. And now the difference here is instead of selecting the none, I want to select access. Access will then give me the option under the multicast here to select IGMP. And so my switch is already configured as a querier, so I want to make sure just the IGMP protocol is selected. I'm going to hit next, follow the same settings here. This is going to be an IPv4 capable client, and if I was using a .1Q tag, I could select this option to impose it, but for now this is just going to be an access layer port example. I'm going to select next, and now I can say how many receivers do I want to be on this particular group, or excuse me, for this particular example. So I'm just going to choose a single receiver, and I want its IP address to be, let's do 10.10.10.100. This will be a little bit later on in the subnet. Still a /24. 1 is my gateway. I don't need to worry about the steps here. And in the previous example, when we created the source, the launch traffic wizard was not selected, and I did that on purpose. Now that I've got a source and I'm configuring a receiver, I'm now going to want to make sure that this is selected so that once I complete this process, it'll now take me into the traffic generation. Now I'm going to hit next, and I get to configure what sort of IGMP protocol do I want to operate. So I could choose from option 1, 2, or 3. So this is going to be an IGMP version 2. And I would like to have either one group, or I could specify more. Let's just to make it easy, I'm going to do 10 groups, just to show that it's very easy to scale this up if necessary. And the starting group is going to be 239.111, and the step, we'll leave it at 0. It'll create just 10 groups, but because I'm only using a single interface, I don't need to worry about the step for now. Once I do next, I could see, okay, here's my client. It's been created with this IP and the starting multicast group. So I'm going to finish the device creation, and now my traffic generation window should appear, which it does. So I've only configured ports 1, 3, and 2, 2. So I'm going to deselect port 1, 4, and 2, 1. Hit next. And so now we need to choose who's going to be our source of this multicast traffic. And so for that, I'm going to select device 1, which is the client I created earlier, and I'm going to map it to this project, this IPv4 group. So this is 1.1 through 1.10. This is going to be unidirectional, 1-to-1, so I've got 10 clients sending to 10 groups. It should give me the .1 sends to 239.111, the .2 sends to 239.112, etc. So I'm going to add this, and now I see device 1, this IP range will be sending to this IPv4 multicast group range. I'm now going to say next, and I'm going to go ahead and give this a name, and let's just call it multicast source. If you wanted to vary things like UDP or port numbers or anything like that, you could select this vary protocol and QoS option, but I'm not going to be doing that for now. And I'm going to leave all these other settings as is. This particular example, I'm not going to have the port also receive traffic. It's just going to be sending it only, so we don't need to worry about that first checkbox, the allow port to generate to itself. Select next. I can now, if I wanted to, create the individual IP header. So if you wanted to modify something like a UDP port number, this is how you could do it. I could add header, And then in the options available to me, I could scroll down to UDP. There it is. Hit OK. I can open this up, and now I can click this and make any sort of modifications I want. So I could say port 5000, the destination port. I can edit this, change it to 5000. In this example, I am sending more than one group. So if I wanted to have multiple groups with a unique set of ports, I could do things called modifiers. So I can insert a modifier here. And if I wanted one group to have, say, 10 different destination UDP port numbers, I could do that here. And I could do this by either incrementing, decrementing, having a list, random, etc. So all these options are configurable, but for now, I'm just going to keep it very simple, only UDP port 5000 and no other changes. Now I want to make sure I have two options here. One is port-based and the other is load per stream block. If I'm going to be adding additional Spirent traffic, then we're probably going to want to stick with load per stream block. And the reason is you can create multiple different streams, and if port-based is set, then whatever value you have on the right here will be the aggregate for all those streams, be it 1 or 1,000 streams. So if I had 1,000 streams, they would always be capped to 10% of the interface's total capacity. By doing something like load per stream block, I can now get more granular. Maybe I can send one stream at a rate of 10 megs a second and a different stream at a rate of 500 megs a second, and I can do anything in between. So I like this because it's a bit more granular and easier to work with once we get into more advanced streams. So now my load mode, I'm going to keep it at fixed, and let's go ahead and just do a simple frames per second. I don't need this thing handling 100 megs of multicast. Maybe I'm just trying to show that I can get a couple different groups going. So my frame rate per second, let's do it at 2000 frames per second for all of the multicast groups I've just created. I can now hit next. I'm going to select the interfaces that'll be receiving this. In this example, only port 22 is my receiver. If you want, you can add all these ports. It's not going to hurt anything. This is just for the statistics and data collection that Spirent uses on the back end. So I'll go ahead and say finish. And now I'm ready to start traffic generation. So I'm going to hop over to port 13. Here's my multicast source traffic stream. Now, because this is multicast, I don't need to ARP out, but if you want to have these clients just ARP out for a gateway, you could certainly do that and just select the ARP/ND, and that'll cause them to ARP out for their gateway if it's there. And if ARP completes successfully, then we'll see that the status icon here will change from this kind of gray, shiny color to green. And if maybe only some of the hosts are able to resolve ARP, it'll turn yellow. But in this case, because I'm only dealing with 10 clients, they all ARPed successfully, and so they turned green. And Spirent has already started some interface statistics for me. So now to start my multicast traffic, I just right-click this and select Start. And now we'll start seeing all my counters will start changing. So my total TX count is actively incrementing. And if I want, I can scroll over a little bit. It's usually hidden on the side here. And there we go. Here's my total TX rate in frames per second. And I can see that this interface is sending 2,000 packets per second, but my receiver is not getting a thing. And this is because I do have IGMP snooping turned on and I'm set as a querier. And because there are no IGMP joins that have been received, the switch is not going to forward any of this multicast traffic. It's all being discarded. So to now start my IGMP client, I'm going to hop over to my client port and click the devices. Here's my emulated device, and you'll notice we have a dedicated tab called IGMP. As it stands, this client for all 10 groups is not a member. I could change this by simply right-clicking it and then going to Start Device. When I do this, it'll now make this client active, and then it'll simultaneously send the number of joins necessary to start getting all of the traffic streams. So we could see now my total TX rate is still at 2,000 packets per second, but now I'm receiving the exact same packet rate. If I hop over to my switch here and I repeat this command, the show IP IGMP snooping groups, I could see now that I've got 10 multicast groups to which this interface is a receiver for all 10 groups. Now, for some reason, I want to stop this. At any point, I could right click and I can mouse over to the IGMP tab here, and I can send a leave for all of my IGMP groups. And in doing so, we'll see it now changes to non-member, and then the RX rate here now goes back down to 0. If I up arrow enter and look at this, we'll see that now all the groups have been deleted from the snooping table. And to join them back up, I right click, go to IGMP, and send my report. And once I do that, I now see that everything gets populated back up. And so that's going to be this very simple example of how we can get multicast traffic running through a Spirent. I hope you found this useful.